Different modes of transport have a different impact on the environment. Carbon distance reflects the difference in climate impact among different modes of transport. For example, the wine industry recently found that a bottle of French wine transported by sea and served in a New York restaurant will have a lower carbon transportation footprint than a bottle of Californian wine served in that restaurant. Transporting goods by sea has a lower environmental impact than road, rail, or air transport. As you've just noticed, shipping is the most carbon-efficient mode of transportation. Nevertheless, the environmental impact of shipping is not limited to greenhouse gases only. It also includes acoustic and oil pollution. On a ship, oil leaks can occur in the machinery spaces or from engine maintenance activities. Oil spills, which may occur from daily operations like bilge water disposal, have devastating effects. Oil and byproducts from the biological breakdown of oils can harm fish and wildlife and pose threats to human health if ingested. Any oil that has accumulated needs to be extracted from the bilge water and either reused, incinerated, or offloaded in port. If the bilge water separator is faulty or is deliberately bypassed, untreated oily bilge water could be discharged directly into the ocean, where it can damage marine life. This will also cause ship operators to be given heavy fines and the crew can be sent to prison. The size and global nature of the shipping industry, over 90% of all trade between countries is carried by ships, makes it important for the industry to continuously work to reduce its environmental impact. Cleaner oceans are a major environmental concern for the shipping industry. The aim is to remove all of the pollutants from engine room bilge water, so that only clean water goes into the sea. In your view, what should be the aim of bilge water treatment? Select the one best answer. To start with bilge water management, you need to know two things: the requirements that must be met before pumping machinery space bilges, and the records that must be completed for machinery space bilge discharges. Most current legislation demands that treated bilge water must contain less than 15 parts per million ppm. To put that into context, if we had a typical 210-litre drum, 3.15 millilitres would be 15 ppm. That's about one medicine dropper or half a teaspoon of oil mixed in with a drum full of water. Depending on your point of view, that's either a lot or not very much. But remember, what we would like is zero discharge. When this rule first came in, 15 ppm was about the limit for what we could reasonably get down to, and what we could measure with reasonable accuracy. Nowadays, however, most bilge separator manufacturers are working towards 5 ppm, which is already a requirement in some localized areas of the world. First of all, we need to be clear that MARPOL regulations are written to try and avoid anyone cheating. So we must not knowingly put things like cargo washings or cargo pump room bilges into the engine room bilges and then say we are discharging engine room bilge water. That would be illegal. Annex 1 of MARPL says that for a vessel above 400 GRT, machinery space discharge outside a special area is allowed when the ship is proceeding en route. The oily mixture is processed through oil filtering equipment, meeting the requirements contained in Annex 1. The oil content of the effluent without dilution does not exceed 15 parts per million. The oily mixture does not originate from cargo pump room bilges on oil tankers. And the oily mixture, in case of oil tankers, is not mixed with oil cargo residues. We will talk about the special areas themselves in a moment, because some special areas are more special than others. However, in most special areas, the rules for discharging machinery space bilges are about the same as anywhere else. The difference lies with the requirements for the bilge water separator itself. Essentially, if you are going to use a bilge water separator in a special area, then it must have an automatic alarm and stopping device. We are going to try and stick with the things you need to know from an operational point of view. The difference between being outside or inside special areas was far greater many years ago, when there was a higher ppm allowance for machinery space bilges outside a special area. Those days are gone, and the reality is that nearly all modern equipment complies with the rules for inside a special area. However, it is probably worth mentioning that there is still a very big difference between inside and outside a special area when it comes to discharges from cargo operations. The supplement to the International Oil Pollution Prevention (IOPP) certificate, issued and checked annually, will tell you, the operator, what system is on board, and therefore how you can discharge the machinery space bilges. These are the listed special areas for MARPL Annex 1, but note that the Antarctic is a special case of a special area. In the Antarctic area, any discharge into the sea of oil or oily mixtures from any ship is prohibited. The IMO also lists particularly sensitive sea areas, PSSAs. A PSSA is an area that needs special protection through action by IMO because of its significance for recognized ecological or socio-economic or scientific reasons, and which may be vulnerable to damage by international maritime activities. Please remember that local regulations often apply, in places like the Great Barrier Reef, for example, and that new special areas are being added to different annexes of MARPL all the time. So always check that you have up-to-date local information. Can you pump machinery space bilges whilst in a special area? Select the one best answer. The Oil Record Book, Part 1, must be accurately completed for every discharge from machinery space bilges. The date, operational code, and item number needs to be written in the appropriate columns, and the required particulars should be recorded chronologically in the blank space. For discharges overboard, the ship's position at the start and end of the discharge should be entered. Each completed operation shall be signed for and dated by the officer or officers in charge of the operation. Each completed page must then be countersigned by the master of the ship. Failure to fill in the oil record book in a proper way has led to those on board and companies being prosecuted. In order to be approved for use on board ships, bilge water separators have to meet tight standards. And these are set out in guidelines from the IMO and in type approvals from classification societies and regulatory bodies. These say that bilge separators should be capable of producing an effluent for discharge to the sea containing not more than 15 ppm of oil, irrespective of the oil content of the feed supplied to it, and that it must be capable of handling emulsions. However, the aim was to produce a discharge as near to clean water as possible. We can help the separator to do this and reduce the maintenance required on the separator if we separate out most of the oil and solids before we start, because most of them will settle out naturally under gravity. Solve this riddle. What might bilge water, mayonnaise and hand cream have in common? Emulsion. First of all, the bilge holding tank is for bilge water. Waste oil or sludge should go to the sludge tank, from where it can either be burned in an incinerator or discharged to shore reception facilities. The piping arrangements should be such that if we are transferring sludge, it cannot end up in the bilge separator tank. There may be some provision to strip water from the bottom of the sludge tank to the bilge tank, but this must be via an open hopper or sight glass, so that we can see that it is actually water. MARPL specifies which arrangements are acceptable and which are not. Here are just a few examples. This arrangement is allowed because the connection is through a sight glass or hopper. This arrangement is allowed because the non-return valve prevents flow from the sludge system into the bilge system. This arrangement would not be allowed because there is a direct connection between the sludge system and the bilge system. This arrangement would not be allowed because there is a direct connection between the sludge system and the bilge system. Separation in the bilge holding tank can be helped by time, heat and calm seas. Calm weather and time will allow the oil and water to separate due to gravity. And heat helps reduce the viscosity of the oil, which speeds up the separation process. A temperature above 50 degrees Celsius is recommended for ships where bilge water might be contaminated with heavy oil. The suction pipe for the bilge separator should be above the heating coils to avoid sucking sediments from the bilge tank and sending them to the bilge separator. To help us separate the oil and water, the best designs of bilge water tanks use at least 2 stages in series, with the first stage overflowing into the second. We will be able to skim oil off from above the surface of the water and also drain sludge and solids from the bottom of the tanks. On a modern vessel, can you transfer any of the contents of the sludge tank into the bilge separator tank? Select the one best answer. As you know, bilge water is water that gathers in the engine room bilges. Unfortunately, on its way there it can become contaminated with small solid particles, detergents and soaps, and dispersants. All of these increase the difficulty of having totally clean water at the outlet from the bilge water separator. The formation of stable emulsions in bilge water creates a particularly difficult situation for the bilge water separator to deal with, since it is harder to separate the water from the small droplets of oil in a stable emulsion. An oil dispersant is a mixture of emulsifiers and solvents that helps break oil into small droplets. Dispersants are often used deliberately following an oil spill. Dispersants are also a constituent within fuel oil additives and lubricating oil additives. Although IMO guidelines are quite clear that bilge water separators should still be effective if supplied with a stable emulsion, we will get improved separation if we can avoid forming emulsions in the first place. The greatest source of chemicals which can cause stable emulsions to form is probably the cleaning agents and detergents we might use in the engine room. We should be using cleaning agents that are listed as being quick separating, environmentally friendly, and non-toxic. Some suppliers will specify that their products are compatible for use with bilge separators. We should also try and eliminate the leakage of fuel oil and lubricating oil additives into the bilge wells, since these contain dispersants which promote the formation of emulsions. Although bilge water separation is a complex and challenging process because of what bilge water can contain, we can use some basic physical forces to help us with it. This learning unit is to remind you of the mechanisms by which separation of oil and particles from water can be achieved. This will help you to understand better how different types of separators work. Do you know which force is present on a merry-go-round, a roller coaster, and a washing machine? That's right, a centrifugal force. The outward force on a body moving in a curved path around another body. Although the ways in which various bilge separators work get put into separate categories, in reality, some of the same processes go on to varying degrees in most types of separators. Coalescence. When particles or oil droplets coalesce, it means that they come together. So for instance, several small oil droplets come together and form one larger droplet. It is then much easier to separate a large oil droplet or a large dirt particle from water. Flocculation. Flocculation is a process by which two or more particles aggregate, stick together, without losing their individual boundaries. A high alkaline pH value promotes flocculation, which is why separators that rely mainly on flocculation often use chemical dosing to raise the pH. Gravity. Nearly all bilge water separators use gravity separation at some point in the bilge water treatment process, even if it is in the bilge tank. Heavy particles, sludge and dirt, sink to the bottom, whilst lighter fractions, oil and scum, float to the top. Centrifugal force. In centrifugal separators, we are really just turning the gravitational process onto its side and replacing the force of gravity with a much higher centrifugal force, which we can generate using high bowl speeds. Let's take a closer look at a typical centrifugal separator system. The bilge water separation process starts in the bilge tank. A variable rate feed pump supplies bilge water from the bilge tank to the separator via an automatic filter. This filter protects the disc stack of the separator bowl from solid particles larger than 0.5 mm. A differential pressure switch controls the cleaning of the automatic filter, and the rate of the feed pump is controlled by the oil in water monitor. The bilge water then goes through a preheater, where it is heated to about 85 degrees Celsius, and via the feed valve to the separator. During the startup or ejection program of the centrifuge, the flow is directed back to the bilge water tank. Centrifuges for bilge water are very similar to the ones we are familiar with for purifying oils. A disc stack is placed inside the bowl to create a laminar flow and improve the separation effect. Oily water is fed into the separator via a centerline feed tube. There are two outlets from the separator, one for oil and one for water. The solids will be discharged from the separator when the bowl opens for periodical self-cleaning. The purified water goes to the oil monitoring equipment before being discharged overboard. The oil goes directly to the waste oil tank. The solids go directly to a sludge tank. In some systems, an absorption type filter may be fitted after the separator. When used, this enables the oil content to be further lowered to below 5 ppm. Most current legislation demands that treated bilge water must contain less than 15 ppm. Nowadays, however, most bilge separator manufacturers are working towards 5 ppm, which is already a requirement in some localized areas of the world. Annex 1 of MARPOL says that For a vessel above 400 GRT, machinery space discharge outside a special area is allowed when the ship is proceeding en route. The oily mixture is processed through oil filtering equipment, meeting the requirements contained in Annex 1. The oil content of the effluent without dilution does not exceed 15 parts per million. The oily mixture does not originate from cargo pump room bilges on oil tankers, and the oily mixture, in case of oil tankers, is not mixed with oil cargo residues. For machinery space bilges, special area requirements lie in the requirements for the bilge water separator itself. It must have an automatic alarm and stopping device. All the details of the requirements for pollution prevention equipment are included in IMO's MEPC 10749 document. Special areas are listed in MARPOL Annex 1. Local regulations often apply in places like the Great Barrier Reef, for example, and new special areas are being added to different annexes of MARPOL all the time. The IMO also lists particularly sensitive sea areas which need special protection because of their significance for mankind. The bilge holding tank is for bilge water. Waste oil or sludge should go to the sludge tank, from where it can either be burned in an incinerator or discharged to shore reception facilities. MARPOL specifies which arrangements are acceptable and which are not. The best designs of bilge water tanks use at least 2 stages in series, with the first stage overflowing into the second. Small solid particles, detergents and soaps and dispersants make the job of the separator more difficult. Avoid the use of cleaning products that create stable emulsions. We should choose quick separating environmentally friendly cleaners. And any leakage of fuel oil and lubricating oil additives into the bilge wells should be eliminated. Most types of separators use many of the same physical processes. Coalescence is when several small oil droplets come together and form one larger droplet. Flocculation is when 2 or more particles aggregate, stick together, without losing their individual boundaries. Gravity. Nearly all bilge water separators use gravity separation at some point in the bilge water treatment process, even if it is in the bilge tank. In centrifugal separators, we are replacing the force of gravity with a much higher centrifugal force.